Hello and welcome back to Gaffy's Grinds. In today's lesson, we're going to talk about something called the combined gas law. Now, in previous lessons, we learned about two of the gas laws, and that was Boyle's law and Charles' law. Now, Boyle's law, if we remember, goes like this. It tells us that PV equals to K. And what this essentially means is that pressure and volume are what we call inversely proportional. That means that if I increase the pressure, so say I went, let's say pressure was originally 1, and volume was originally 1, then of course 1 by 1 would be equal to 1. So k, the constant here, will be equal to 1. 1 times 1 equals 1. Now, because k is constant, it has to stay the same. Stays the same. It has to stay as 1. If we vary the other two, the p and the v, we see that k has to stay 1. We can see what happens to p or v if we change the other one. So, for example, the best way I can do this is say, let's say we took p and we took it from 1 and we put it up to 2. So we increased P. We doubled it. Okay. So what has to happen to V in order for K to stay 1? K has to stay constant, remember? So K has to stay as a 1. Well, what has to actually happen here is that this has to go to 0.5. And that's because 2 by 0.5 is 1, right? So if we increase P, we actually have to decrease V in order for K to stay constant. So we say that when P increases, when P goes up, V goes down. And that is true so long as we keep the temperature the same. This is Boyle's law, PV equals K. So Boyle's law explains for us the relationship between P and V. We also learned about Charles's law, V over T equals to K. And again, we have a constant K, so let's let that be 1. Okay, let's let K be 1. And again, let's say that volume, V, is 1, and then T has to be 1. Okay, and if you think about this, V over T, 1 over 1 equals 1. That's true. 1 divided by 1 gives us 1. So again, Charles's law lets us look at, by keeping this constant, lets us look at what happens to one of these other variables, V or T, when we change the other one. So again, let's do an experiment here. Let's take V and put it from 1, instead of being 1, let's put it up to 2. Okay, so we've increased V. That's what we've done there. We put V up. So what happens to T in order for K to stay the same? Well, as you can see here, T is also going to have to go up to 2, because 2 over 2 keeps K 1, right? 2 divided by 2 is 1. So we see here that if V goes up, T has to also go up. Okay, and that is Charles's law. So that's the relationship, says that volume and temperature are directly proportional. Or volume varies directly, volume changes directly with temperature or Kelvin temperature for a gas at a given pressure, if we keep the pressure constant. So that's Charles's law. Now, let's take this following scenario. Imagine you have a balloon full of a gas. It has a certain volume because it's in a balloon. Now imagine that you want to increase the pressure. So this would be Boyle's law, but also cool it way down. That's Charles' law, right? So this is two things varying at the same time, right? Pressure is changing, but so is the temperature. Okay, so we can't use either one of these laws. It's just find out what will the new volume of the gas going to be. Neither Boyle's law or Charles' law can help me solve this problem, as those laws only relate two variables at a time. These two laws, however, can be combined to give a new law that will really help us think about all three variables at one time. It goes like this. P1 V1 over T1 equals P2 V2 over T2. This is what each thing stands for, okay? Now, at this point, what I'm going to do is I'm going to ask you guys to pause the video and make a note of this as the combined gas law, and also writing down what each of these things stands for, please. So doing that for me now. Okay, so now that you have that done, guys, we're going to show you how to use this law. Okay, this here, by the way, I didn't write it down. It's called the combined gas law. Combined gas law, because it combines some of the other gas laws. Okay, combined gas law. There's actually a third gas law in here as well. Okay, which you could probably, some of the students who do higher level maths could probably derive that law from here, but it's not really on our course, so we don't really do it. Okay, but if you look at the I suppose the gas, particularly you look at one side of this here, we see P1 and V1. P is proportional to V, okay, and that is up here, PV, okay, and that is essentially telling us Boyle's law. And then we also here, as you can see, have V over T, okay, V1 over T1. There is Charles' law. There it is there, look, okay, and you can see where's the third one going to be. You can probably see it's going to be P over T, right? Okay, and you can see which one you got to keep constant in each situation, right? So for Boyle's law, it's P1 V1, the red square here, and you got to keep temperature constant, right? For Charles' law, it's V1 over T1, you got to keep pressure constant. And for this other law, it'd be P1 over T1, you got to keep volume constant. That's a different law. I'm not going into that now today. It's not really on our course, but you can actually see how they are related, and you can maybe derive the definitions from it if you just know this combined gas law. And this combined gas law, unfortunately, is not in the log table, so this is something you have to learn. Now, what we're going to do is we're going to show you how to use it, and a key piece of information here is you're always going to be supplied with 5 pieces of info. Pieces of info here, 1, 2, 3, 4, 5, 6. You're going to be supplied with 5 pieces. You may have some additional calculations to do to work out some of these. You might be given no, you're usually given them. You might be given a temperature in degrees Celsius, and you might have to convert to Kelvin, something like that. But in general, you're given 5 of these pieces of information, and you have to work out the 6th one. Okay, so I'm going to show you how to do that now, how to work this out. So let's say we have an example. Let's say we're asked, I'm going to keep it really generic. Let's say we're asked to calculate a final pressure. Asked to calculate, sorry, rubbing out here. I'll do it for my calculate the final pressure. And you're given all the other pieces of information. This is not a real example. We're keeping it really general here. We're keeping it really generic here. So we're going to find out what do we have to do to this equation, P1 V1 over T1 equals to P2 V2 over T2. What do we got to do to solve for P2 if P2 is our unknown? Now, what we're saying here is that we've got P1, V1, and T1, and each of them is known. They're given to you. We've then got P2, V2, and T2, and what we're saying is that V2 and T2 are given to you in the question. So how do we take this equation and rearrange it in order to be able to solve for P2? So essentially what we're going to do here is we're going to do what we call linear rearrangement, which you guys should know from maths, okay? Should know how to do it from maths. But essentially what we want to do is isolate this variable by itself. So here is this variable here, P2, that's the one we want to isolate. What we mean by isolate is it just means we want it to be on its own on this side of the equal sign. So P2, and we want the other things that are here. So of course, this is P2. Currently, it's been multiplied by V2 and it's been divided by T2. We want to get rid of them, okay? But you can't just rub them out and pretend that they're not exist. You've got to do some operations to get rid of them, okay? So how exactly do we do that? Okay, well, what we do here is we can do some operations to both sides of the equation. This here is equals, and what that means is do the same to both sides. That's what you have to do. If you're going to make a change, you've got to do the change on both sides, keep it balanced, right? So essentially what we want to do here is we want to remove V2. That's the first thing. We want to get rid of that. But you can't just rub it out, right? However, what you can do is you can divide by V2. If we put V2 in the denominator here, that'll mean that V2 divided by itself always goes to 1, right? It always reduces to 1. However, you can't just do that on one side. You must divide both sides by V2. So that means I must do that over here as well. I must put it in the denominator on the right and the left-hand side. You see what I've done here? I have to put it in the denominator on both sides, and I can cancel it or reduce it to 1 on this right side because it's V2 on the top and V2 on the bottom. Right, the other thing I can do is I can cancel this T2 by putting it in the numerator as well, right? Because now I've got T2 divided by T2, okay? So you put it in the numerator, or that's the same as multiplying. So multiply both 2. That's how we multiply. So now everything on the right has been reduced to just P2. Everything else has been reduced to 1. So that's just P times 1 over 1, which is just P, okay? So we've got the P2 here now, equals, and now we've got all this stuff on the right. T2 times P1 times V1 over V2 times T1. And that's our calculation, or that's our equation now that we can use to solve for P2. Now we sub in T2 value, P1 value, V1 value, V2 value, and T1 value. Plug them in, put it in your calculator, and you'll get the answer for P2. Right, so let's try a real example of this now. Let's have a little look at the following. So I'm going to ask you to pause the video and have a little read of this there for me. Now, okay. Now what we're going to do is we're always going to start out by writing each of these pieces of information that are in our equation, P1, V1, T1 equals, and equals of the equation P1, V1 over T2. Okay, so that's the equation we're going to use, and we're going to fill this section in from the information in the question. So let's say it says a gas here has a pressure, there's pressure of 10 atmospheres. So let's assume that's the beginning pressure, 10 atmospheres, 10 ATM. A volume of 24 liters, and a temperature of 200 Kelvin. So 200 Kelvin. So this is the first set of conditions. They're the original conditions. And it then says calculate the volume when I raise. So we're making a change. We're changing. Pressure's going up. So pressure 2 is 14 atmospheres. Increase the temp is going up to 300 Kelvin. And we can clearly see that V2 is the unknown here. This is the missing one. This is the X or the question mark. And it even asked that in the question, look, calculate the volume. So V2 is what we're solving for. So what we need to do is we need to rearrange the equation to get V2 now. Okay, so again, let's take this equation over here and see what we need to do to it. I'm going to do it in purple, the changes I need to make. I need to isolate V2 right there. So I'm going to do this by putting P2 in the denominator on both sides, because that helps me reduce that P2 that's in the numerator there on the right hand side. And then I need to also, of course, get rid of the T2. So I'm going to multiply by T2 or put it in the numerator. And then T2 over T2 reduces to 1. And then I'm going to do the same thing over here, T2 in the numerator. Okay, so let's rewrite it out here. We've got T2, P1, V1 over P2, T1. And all of this is equal to V2. Now we're going to put in our numbers and solve for V2. So T2 was 300. P1 was 10 and V1 was 24. All that is over P2, which was 14, and times by T1, which was 200. Right, so I'm going to put that in my calculator, and that's going to give me V2. V2 is equal to, what you should have got here is 25.714. Now I need to know my units. My units are going to be equivalent to the units that I put in for the other volume. But up here, you see that it was in liters, 24 liters. So this is now 25.714 liters. Thinking about that logically, does that make sense? What have I done to the temperature? I've put the temperature up. So that should increase the volume. And what else have I done? I've also put the pressure up. So that should try and decrease the volume. But which of them is actually going to win then? Obviously, the temperature won because the volume has gone up a little bit. It went from 24 up to 25.714. Right, guys, I'm going to ask you now to, you can pause the video and take that down as an example. Then what we're going to do is I'm going to get you guys to have a crack at this one. Okay, so pause the video and have a crack at this one. Okay, so I'm just going to give you the answer here. If you didn't get this, you need to have another little look at it. You should have got 190.84 liters, and that was going to be your V2. So that was solving again for V2. So same rearrangement as in this other worked example. Sometimes you might have to solve for one of the other variables, so you got to rearrange the equation in a different way. For some practice there now, I'm going to ask you guys to work your way through questions underneath that sample in the booklet here. In this version of the booklet, it was 153 to 157 is an exam question. So I'd advise you to do that one as well. 153 to 157 should give you a bit of practice with these. So you do them, guys, and we'll have a little look at them in the next video. All right. Thanks very much for watching. I hope you found it helpful, and I'll see you in the next one.